So the last assignment given has not been submitted. So I will not do the correction to the assignment until I get the assignment. Okay, so I'll continue with last class we treated standard form. So today we are still continuing with standard form. Last class we talked about standard form generally, then basic operations in standard form, addition and subtraction. So today we'll be dealing with multiplication and division in standard form. Multiplication and division in standard form. Let's take examples. If we are asked to evaluate the following. One, given 9.06 times 10 raised to power minus 9 divided by 5 times 10 raised to power negative 6. And the second question, we have 8.01 times 10 raised to power 8 times 6.51 times 10 raised to power 5. Multiplication and division in standard form. So let's come in welcome. So evaluating the following solution. The first question is 9.0 times 10 raised to power minus 9 divided by 5 times 10 raised to power minus 6. So if we're asked to solve this, how do we go about it? Last week I explained that we pick the common term or the common digit to both sides. This is the first term, this is the second term. Now, what is common to the first term and the second term? 10 raised to power minus 6 is common to both sides. When we bring out 10 raised to power negative 6, let's see. So 10 raised to power minus 6, I wrote bring out the common term. 10 raised to power minus 6 is common to both sides. So we have 10 raised to power minus 6. When we bring out 10 raised to power minus 6 from this place, we have, what do we have left? 9.06 times 10 raised to power minus 3. Because when you add up 10 raised to power minus 6 times 10 raised to power minus 3, using your indices rule, multiplication changes to addition, you have 10 raised to power minus 6 plus 10 raised to power minus 3, which gives us 10 raised to power negative 9. So divided by, bringing out 10 raised to power minus 6 here, in the second term, we have 5 left. So this gives us, now writing this as in ordinary form as an ordinary number, 9.06 times 10 raised to power minus 3 gives us 0.00906. Oh, sorry. So this gives us 10 raised to power minus 6 into 0.00906. 0.00906 divided by 5. So when we divide this, what do we have? Who can give me the answer? Hello? 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 Anyone with a calculator there? Okay. Hello? So we have our 10 raised to power minus into 1.812 times 10 raised to power minus 3.
Yes.
So from here we have 10 raised to power minus 6. When we divide this, we have this equals to 10 raised to power minus 6. Writing this in standard form, they have 1.812 times 10 raised to power minus 3. Like I explained last class, your power is determined by the amount, by how many times the decimal point moves. This is from here moving to after 1, we have 1, 2, 3. That's what makes it 1.812 times 10 raised to power minus 3. Now brackets in mathematics means multiplication. So we have 10 raised to power minus 6 times 1.812 times 10 raised to power minus 3, which gives us 1.812 times 10 raised to power minus 6 times 10 raised to power minus 3. Applying the law of indices to this, this gives us 1.812 times 10 raised to power minus 6 plus minus 3, which gives us 1.812 times 10 raised to power negative 9. Minus 6 is minus 3, minus 9. Or the other way we can go about this question, which is 9.06 times 10 raised to power minus 9 divided by 5 times 10 raised to power minus 6. The other way we can go about this is writing it out this way. We have 9.06 times 10 raised to power minus 9 over 5 times 10 raised to power minus 6. So this gives us 9.06 divided by 5 times 10 raised to power minus 9 divided by 10 raised to power minus 6. (9.06) divided by 5 gives us 1.812 times applying the law of indices to this, we have 10 raised to power minus 9 minus 6, which gives 1.812 times 10 raised to power minus 9 plus 6 is 1.812 times 10 raised to power minus 3. Sorry. There's a power. I'm trying to check out where the mistake is. Sorry. I'm taking my time. This is I'm trying to check out where the mistake is here in the 2 questions. I think I'm not getting it. Let me just clean this. I'll probably come back to it next class. I don't want to waste our time. I'll check where the mistake is. Sorry about that. Okay, let me go to the second question. It said, as sorry. Okay. 8.01 times 10 raised to power 8 times 6.51 times 10 raised to power 5. So solving the second question, 8.01 times 10 raised to power 8 times 6.51 times 10 raised to power 5. Bringing out the common value, we have 10 raised to power 5 common to both terms, the first and the second term. So when we bring out 10 raised to power 5, we have 8.01 times 10 raised to power 3 clear times 6.51 left in the second term. Now when we write this out as ordinary number, we have it to be 10 raised to power 5 into 8.01 times 1000 times 6.51. 10 raised to power 5. This gives 8010 times 6.51. So this gives 10 raised to 5 into. Can anyone do this multiplication for us? Hello? Okay. When we multiply this, we have 52,145.1. This gives 10 raised to power 5 times 52,145.1. When we write out 52,145.1 in standard form, this gives us 10 raised to power 5 times 5.21451 times 10 raised to the power of 4. So this gives us 10 raised to power 5 4 times 5.21451, which gives us 5.21451 times to the power of 9. That will be our answer. Do you understand? Do you understand? Hello? 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 Okay. Can I clean the board?
Continue with the class. I don't...
Okay. So that will be the end of well, before we move on to I quickly want to treat an aspect of indices. It's a question that comes out in senior secondary external exams, simple exponential equation. And it's kind of, how should I put it? It's different from the normal indices, though simple. Yeah, so simple exponential equations. I want to come back to this. Example, we are asked to solve 3x raised to the power of minus equals to negative 27. Now, this is a subtopic under indices. You apply indices in solving equations like this. Just that questions like this sometimes lead you to simultaneous equation where you have to use substitution and all of that. So we are asked to solve 3x raised to power minus 1 over 2 equals to negative 27. How do we go about this? 3x raised to power minus equals to minus 27. Now, to solve this, the first thing we have to do is we divide both sides by 3. Because to solve this, we have to have just our base and then the power. And if we're having 3x as our base, it's not easy for us to solve it. So what's the first step to do in this case? You divide both sides by 3. And when we do that, we have 3 raised to power negative half. So we have x raised to power minus half equals to minus 9. Now, this is where we apply indices law. We are having a fractional indices in this case. And when you want to solve questions like this, the best way to solve questions like this is by comparing both sides. Now, if we want to compare both sides, is either we have similar, what's it called, base, or we have similar power. If we have x raised to power minus 9 equals to x raised to power minus half equals to minus 9, we cannot, another thing to note is we cannot solve this because we have a negative number. So another thing you do is multiply both sides, or we say find the square of both sides, square both sides. Don't forget that in mathematics, once you do whatever you do to the left hand side, you do to the right hand side. Once you do that, the equation is balanced. So we are squaring both sides. If we square both sides, we have x raised to the power of minus half squared equals to minus 9 squared. When we square this, we have x raised to the power of minus half times 2 equals to minus 9 squared, which is minus 9 times minus 9. So this gives us x raised to 2 cancel 2, so we have minus 1. And this gives us positive 81. So we have x raised to the power minus 1 equals to positive 81. X raised to the power of minus 1. When you cross multiply both sides, we have 1 is equal to 81x. Divide both sides by what? We have 1 over 81 is equal to 81x over 81. So we have our x to be what? 1 over 81. Do you understand this? Do you understand this? Hello? Hello? Okay. Can I clean the board? Still on simple exponential equations, we take another example, example 2. If we are given that 7 into 8 raised to power n plus 1 is equal to 448. Find n. Now we have to solve for n in this equation. So we have 7 into 8 raised to power n plus 1 equals to 448. So like we did in the other one, the first thing to do, we divide both sides by 7. So we have 7 into 8n plus 1 over 7 equals to 448 over 7. Dividing this by 7, we have 8 raised to power n plus 1 equals to 448 divided by 7. 7 in 44, we have 6. Remember 2. 7 in 28, we have 4. This is 8 and 8 raised to power n plus 1 equals to 64. Now, how do we go about this? If we want to solve this, looking at our left-hand side and our right-hand side, I said the best way or one of the ways of solving this is to compare both sides. Now, if we want to compare this, we have 8 raised to power n plus 1, we have 64. How does it align? It does not align. So what do we do next? We have to think of a way of breaking 64 down. This base, this one that is ordinary base 64, we have to find a way of breaking it down to a base and power. Break down into base and power. And now we don't just break down into any base and power. We have to be sure that the base and the power we are breaking down to have a correlation with this. Now we have 8 raised to power n plus 1 and 64. When we look at 8 raised to power n plus 1 and look at 64, looking at 8, looking at 64. 8 times 8 is 64. 8 squared is 64. So we can say 8 raised to power n plus 1 is equals to 8 raised to power 2. 64 is the same thing as 8 raised to power 2. In this place, what do? You equate indices. When we equate indices, the bases are equal. They have equal base. So what happens mathematically is this. Whenever you have equal base, you cancel the base on the basis that they have equal base. So we have n plus 1 is equal to 2 left. If n plus 1 is equal to 2, then what do? Collect like terms. When we collect like terms, we have n is equal to 2 minus 1. So our n is equal to 1. That is our n. Do you understand? Do you understand? Okay.
Please, Maurice, let me write it though.
Do you have any question from everything that I've been taught today or in previous classes? Hello?
Ma, you have 9 minutes to go.
Okay, thanks.
You can clean the board.
If we are asked to simplify something like this, 4/25 raised to power of half. Note that this power of half belongs to both sides, both the numerator and the denominator. And I explained when we have fractional power, fractional indices, you break down your base into a base and a power, whereby the power is similar to the denominator of the initial base we have. So breaking 4 down, we have 2 raised to power 2 into half over 25 is same thing as 5 raised to power 2 into half, which gives us 2 raised to the power of 2 times half over 5 raised to the power of 2 times half. When this cancels this, we have 2 raised to power 1 over 5 raised to power 1. Our answer is 2 over 5. Do you understand? Next class will be moving into logarithm. Any question? Any question? In the absence of question, we have come to the end of the class today. Thank you. I'll be expecting our assignment during the week.
Please, ma, is that the x 3 raised to power x minus 2?
Where? Where? Is it in the assignment? Hello? This is 3 raised to power x. If this is what you are talking about. I don't know the minus 2. This is 81. This is 4 point. That's all for today.